the footprint and PCB layouts. For this reason, I wanna just draw a simple schematic circuit for a blinking LED using PIC microcontroller, and then transfer it to the PCB layout and see how the layout is. And if we want, for example, use multiple layers, what should we do, and so on. Just let me share my screen with you. Okay. Firstly, I will create a new project. I see project 3. And I will start the schematic viewer. Firstly, the first thing that I need to add is my components. We will use a PIC 16 F84A. I think we will use this one. And we will have another component, a crystal, to generate the clock for this microcontroller. As you know,
sorry, so this is a piece of memory and we're putting a clock into the memory?
The crystal? If you mean the crystal, we use crystals to generate clocks for microcontrollers. Some of microcontrollers have them intrinsically, and you don't know to use a crystal for them because it's designed inside them. And using just programming, you can just set the clock of the microcontroller. But some of them doesn't contain any crystal, and you can use, for example, crystals with different clock cycles, like, for example, 8 megahertz, 16 megahertz, to generate a clock for your microcontroller. Also, I can, for example...
Oh, so we're using a microchip that's meant to take a little crystal oscillator. I got it.
Yeah. For example, crystal electronic, to show the, for example, something like this, the crystal. For example, this one is for 12 megahertz. We have 8 megahertz, 4 megahertz, and 16 megahertz as well, with different shapes, not only just this one, but mostly on circuits and boards. When you see it, looks like this. Okay, and now we will add 2 capacitors. And 1 resistor. One LED. It's a simple circuit for generating a blinking LED. as I mentioned, we will use crystal this way. Now the junction here to connect the ground here. And we need a VCC to bias our microcontroller. And another important thing is to use the power flags to determine that our power ports are as power signals. And then another pin I will add here to make a pin on my PCB to, for example, add the VCC and ground. I will use a terminal, but it's better to use, for example, pin header, but it's just for training. I'm adding this here. And now, as we mentioned in the previous sessions, we will annotate our design to give number for each component of our circuit here. And then running ERC.
Quick question.
Oh, yes.
How did you know to add those capacitors and then to ground?
It's just a circuit to generate the crystal. If you search on the net to see how we generate clock for our microcontroller, usually we use some circuits like this, and it depends on the intrinsic characteristics of our crystal. That if you study about them, you will see. But it's not the subject that we should cover in this course. That's just for showing how we are dealing with different components in when we are trying to design a PCB for our circuit.
So is that what you want us to have on the circuit we have to design for class for the 8086?
No, not just. I want to just show a circuit that you, for instance, to design the PCB for that. It doesn't have anything. It's just a circuit. I want to just show you the procedure of generating a PCB for your circuit. It's a general thing. Also, the problem I had, I didn't use these pins. I should make them not connected. If not, I will receive errors in ERC. Now it's finished. I didn't receive any of the errors that I received before. This is now the schematic part of my circuit. And now I will go to the generating the footprints for different components in my circuit. As you can see here, we have this button here, assign PCB footprints to schematic symbols, and we can use this menu bar to go to that part using this button, assign footprints. If your design is more complicated, it will take a while. You should wait for it. Now you can see all the components of your circuit. Actually, I made a mistake before going to that part. Let me just define the values for these components. It's 22 pico. All right. 22 picofarad. This is, for example, 8 megahertz, because this is an 8-bit microcontroller with 8 megahertz frequency. To 20K register here, and I think it's enough. Just again, complete here, and now I will go to using this button to design my footprints. Not design, just add them. If you want to add footprints for each component, you can use this menu beside this part. You can one of the important things that you can view the design for each of them. For example, if you choose battery, you will see different DIP and SMD designs for your components. For example, this is a capacitor. I will use a capacitor here, for example. These are the designs for capacitors. For example, I will choose this one. Double click on it. Again, I choose the 5mm one. Yeah. Yeah. Sure, yeah. It's this. I will double click on it. As you can see, it's been added here, the component. And if I come on it, you will see the design for the capacitor. I have LED. I will go to LED part, for example. Actually, the difference between these SMD and THD is that in SMD, the components are very small and it's just on one layer of your circuit mostly. But in DIP, all the components have some parts that could go inside the design. For example, we can see here that what's the difference between the capacitor SMD. The SMD capacitors are like this, but the DIP capacitors are like this. These are DIP capacitors, and these are the SMD capacitors, as you can see. Now here for LED, I will choose, for example, this one. For resistor, I will come to find the resistor here again. Choose this, for example. And for the PIC, I will come here, package, deep here. Let's just check how is our PIC 16F84A, how many pins it has. We use the DIP format of this microcontroller because we are trying to design the DIP I think just let's check this way. It has 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9 pins. 9 multiplied by 2 is 18, actually. I think we'll choose this one. And
Richard, please save us.
Can you hear me? I'm sorry, my internet quality is really bad.
You're back for the last 15 minutes.
Oh, I'm sorry. I was
not
teaching for
ignored you.
myself. I was teaching for myself. I didn't know, and Arnav sent me an email that where are you? I'm sorry. I didn't know that I was disconnected. It was a problem in my internet. Just let me again go to the let me share my screen with you. Can you see my screen now?
Now we can.
Thank you for feedback. I think all of you could see the screen for designing the schematic part, yeah? And
We saw when you placed the LED and then nothing after that.
Okay. I will try that again. In this part, we will try to add the footprints. Here, for example, if you add this view selected footprint, you will be able to see the schematic view of your design that you are choosing. For example, this is a capacitor. I will choose the capacitor for. I will choose this one, for example. I will double click on it, and again, I will choose this one. I think D5 2 millimeters. D5 2 millimeters. And for LED, we choose this like this. We will come to the LED. LED, and we will choose a proper one. For example, I will choose this one for terminal. For the terminal that I choose, I will come to the terminal part. Okay, as you can see, we can choose different shapes for this. I have chosen this shape for the terminal, this footprint. For resistor, I will come to the resistor part. Can you hear me?
We can hear you.
Oh, great. And we have the resistors here now. The resistor.
Can't hear you anymore.
You can't hear me? Can all hear me? Please give me a feedback. Then I think your connection has problem now. Maybe if you join the session again, it will be solved. Okay, now for the resistor. For example, I will choose this shape, this footprint actually for the PIC microcontroller. As I mentioned before, we will come and check the chip's name. I have used this one. Let's see how many pins it has. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 multiplied by 2 will be 18. Okay, we will come to the package DIP. We will come to package DIP, and we will choose an 18-pin one for this main. And we chose this one for the crystal. I will come to the crystal because you can see the footprints here because I have chosen them before when I was teaching and I was disconnected. For this reason, you can see here, but I'm doing the procedure again to show that for you. For crystal, I will come here. There are different footprints for that. I will choose this one because I usually use these kinds of crystals in my circuits. I will choose, and it depends on your components that you are using for a circuit. You should design based on them for your footprints. But there is no problem because I think you won't need to create your circuit. Practically, it's just a way to show that you know how the 8086 processor will work. Then after choosing all the components, you can check the footprint of them. And if everything is okay, you will click on OK. And then we have run the ERC and everything was correct. And now we will generate the netlist using this button here, generate netlist. You will click on generate netlist and you will save it in the project directory. After doing this, you will come to the run PCB new to lay out printed circuit board, or you can use this menu, open PCB editor. Okay, I will come here. You can see the window for layout. Everything is clear. Is anyone that has any question about this? Any problem? If you couldn't understand, please tell me. Everything is okay? Great. Now, the important thing that you should do is to load the netlist here. You can see this button here, and I think we have another one here in one of these tools here. Here in tools, load netlist. You can find that too. I will load my netlist. I will choose this address, the directory of my project where I saved the netlist when I was generating the netlist in the previous part. I will choose this one and I will choose the update PCB and close it. You can see the footprints here. I will zoom on it. This is my crystal. These are my capacitors. This is my terminal. This is resistor, and this is LED, and this is the microcontroller. An important point here is that you should place the components on your board in a way that prevent any junction between these connections. Because now we are working, we have just two default copper layers here, and it's really difficult to manage all the connections correctly. For this reason, because you are in one copper layer, it's possible to have a problem in connecting different tracks together. To prevent any in them, we should place them in a good way. For example, I will choose this resistor here. I will bring it here. I will choose the terminal. I will bring it. Can you hear me, guys? Okay, great. Now we will I will transfer the other components like I think I should bring the LED here. Yeah, it will be better because these are the connections. And an important issue here is to rotate this, because you can see here that we have a connection here. To make it easier when we are tracking, we will rotate the design like this. And then we have this capacitor here. We will rotate this like this to prevent any problem in the future. We have this one. I think I should rotate this. Okay, I will share it again now. Sharing. Can you see my screen now? Oh, great. Then we are now we will try to connect these pins together. For this one, after finishing this part, you will choose the route tracks. Connect this. And this is our ground. And it's really easy process because you can see every connections here. For example, this pin will go here. You can see that it's going, and based on that, you will choose to connect. I think it's good. Okay, now we have connected this one, and this one we are connecting. The other one is this ground pin. And again, this one for ground. And these are connected. And the last one is my VCC port. It's a little bad, I think, this track. I will try to delete this one and draw it again. And this is the VCC. Now all the tracks are connected together. Do anyone have any problem? Please give me a feedback. If you have any question, please ask. Can you hear me? Great. Also, I forgot to mention that I have posted the tutorials for this part in Blackboard last night. You can find them here in the assignments, labs, discussions, lab 9. You can find two useful links and two parts, one for adding footprints and PCB board layout design, and one the board layers. Tutorials for each of them. Each of them are 3 or 4 pages, I think. Find them and use them. Okay, now we have the connections here, and we should just be careful that, as you can see, we are on front copper. We have drawn these connections, these tracks on the front layer. If you wanted to, for example, draw your track in the back copper, you should using this. By clicking on this, you will go to the back copper, and by clicking on this, you will front copper. Because I chose this one, all the tracks are on the front copper. After finishing this, you will put this design inside Polygon. And then after finishing and connecting all of them correctly, they are it should be connect the beginning and ending part together completely, and then pressing finish.
We can't see your screen anymore.
Okay, I will share this screen again. Can you see now? Great. Now, as I mentioned, you should put your PCB design in some border lines using this button at graphic lines, and you should be careful to connect the beginning and ending parts together to prevent any problems in the future. And now I will run ERC again. Everything is correct. We don't have any problem here. Everything are connected correctly. And now, because our design is complete, we can see the 3D coming to view menu bar, and you choosing the 3D viewer, you'll be able to see the 3D design of our circuit. As you can see, this is our microcontroller. These are two capacitors. This is my crystal. This is LED, and this is the resistor. And this is the terminal that I can add the VCC and ground. This is ground and VCC. Actually, if I was choosing a pin header here, it was much more better. It wasn't like this. At least I had some connectors here, but it was just for training to show that. And as I mentioned, because I chose the front copper, all the tracks are on the front copper. Yeah, at the end of project, you can see the 3D design of yours. And as you can see in the back copper layer, we don't have any connection because I chose the front copper layer to connect the components together. Also, another important part of this project is designing multi-layer components. For this if you want, for example, to add some more layers, we have two layers now, one front layer and one back layer, as you saw in the 3D design. We can add more layers, for example, two other layers, one for example, for VCC and one for ground. For example, if your design is much more complicated and you can't find a way to connect all grounds and VCCs together, a practical way is that to determine one more layer for VCC and one more layer for ground. In this case, you will be able to use some vias in order to connect your track to VCC or ground in every place on your board. For example, this one is ground signal. I will delete this one, this track. I will delete this one. Okay, I have deleted this track, and now by clicking add field zones, for example, here, sorry, I should do another just we should define more layers here. I forgot the menu for that. Just let me check the okay. From file, we will come to board setup. Okay, here we have two copper layers, as you can see. We can change that, for example, to 4 layers, parts on front and back, for example. Just let me to go to the custom, for example, 2. We have 2 layers here, as you can see, FCU, front copper, and back copper. We come to this one, the 4 one. We have now 4 layers here, 1 front, back, and 2 was added. We will choose the power plane. For this type, these are signals and these are power planes. 1 for GND and 1 for example, VCC that I mentioned it as PWR, as power. Can you see the screen and can you hear me? Great, thank you. Now these are ground and power. We chose them, and okay, as you can see here, we had the front copper and back copper, and now we have 2 other layers, GND and PWR. I will change it to GND, the layer. I will choose this add field zones here. Now you can see the GND layer. I will choose the net GND for that, because GND is my ground. Okay. Now I will click here, and double click here. This is the ground layer. Now, if I come here, I don't have for. Just let me first define the power layer as well, and then go back there. Again, we will choose this. We will choose this add field zones. We will click once in a in part of our circuit in one of the borders. We will. I think power. Okay, now you can see the power and the VCC. We will choose the power layer as VCC and we will click OK on it. We'll come and choose, and this is a power layer. Now we go back to the front copper. As I mentioned, we deleted one of the ground layers here. You can, for example, connect this layer to ground, this port, this net to ground like this. Choosing the track, for example, come here. Okay. Now we can put a via here using this button here. If you zoom on it, you can see it's ground. It means that this track is connected to the ground layer. Instead of coming the long way to here, if you have a complicated design that which you will have because of the project, you can use these properties of designing the PCB here as multi-layer design. You can do the same for VCC as well. For example, if you delete this one and track and add vias here, zoom on it, you will see that it is VCC. It is connected to VCC. Then we have 4 layers and that's it. Any question? Please ask if you have any question about this part. Yeah, that last BIOS is connected to VCC because why it's VCC? Because when I was defining the power layer, can you see I defined the power layer as VCC? That's it. That's why it shows that VCC. It's the name of layer, and I chose the net VCC, which is connected to the power layer. I mean that all power layer, PWR layer, is VCC, and all the GND layer is GND. That's the name. Guys, can you hear me? Hello? Great. What was the question? Is the original ground and VCC on the top layer redundant now if we use the... yeah, it's kind of redundant. You can use that, and also just I mentioned that, for example, if you have some problems in connecting your, for example, tracks to the VCC, for example, you have a bunch of other tracks here, and if you want to track the VCC on up to here, it means that you are connecting this track to other tracks, which is not good because your circuit will be destroyed in this case, your design. In that case, we are using vias. Actually, yeah, it's redundant because you have VCC here, you can connect it here now because you don't have any more tracks here. But if you have other tracks, it's impossible to connect this track to this ground, for example, because in that case, it will be connected to the other tracks of you. I mean that. Yes, we need to set up. As I mentioned, I chose that terminal here, but it was possible to choose, for example, pin headers for your circuit, and then using an external power supply, you can connect the VCC and ground to your board. Actually, I showed the 3D part. Our VCC and ground here is like this. You can just, instead of terminal, add some pin headers here. You will have 2 ports then here. You can just connect VCC and ground using this one. Is everything clear? Yeah, just for more information, some students during this week asked me that what should we do. I will again tell that the only thing that you should do is partial part of the project. It's not the full part of the project, it's just 20%. And the only thing that you need to do is to design the interaction between the 8086 min and the memory part, and how you are multiplexing the A/D part, A/D ports, the control parts of your design. No, you don't need to create a separate PCB for each bit in your schematic, because the only thing that you are doing that is because that design is the schematic part will be a little confusing. You are doing them in the spreadsheet, but your PCB will be just one board. Because in that case, you won't have any problem, because in the PCB part, you can see that which port is connected to where. You can track that. But in schematic, because you are designing that yourself, maybe you make a mistake if you put all of them on one page. Please practice. The second that I have drawn, let me share my screen with you. I can do a much more better way. I can take a picture of my circuit and share it with you, and you can practice it now. In the shared folder, I shared the picture of my circuit linking LED using PIC 1684A. I suggest you to try to implement this by yourself now to see that you have had any problem in the procedure of drawing the PCB and layout. You can use it to tutorials that we have uploaded the Blackboard. You can use them. Just let me show you how I had the big split in. Just let me share my screen again. Okay, you see my screen now. Can you give me a feedback? Okay. Here you can see this here. There is no connection flag. Because we haven't used these nodes, it's better to put these no connection flag on them, because if you don't do that, then you will receive error in performing electrical rules for ERCC in your design. You're welcome. Can you see the picture of my circuit here? I have shared it with you. Great. Then try to design this. All the components' names are mentioned. It's the power flags are a part in the keycap, because sometimes the power nets in your designs are defined as output or input. In order to show that the VCC is a power supply net, you should add power flag to this to determine that, in order to prevent any problem in the running ERC. Just let me, I have a link here, I can share it with you about the power flags. If you remember, I received that error in the 2 sessions ago when I was designing the LM555 circuit, because of that, because of not defining the power flag. Just let me share this link with you. It will be useful. You don't have chosen any group for yourself until now. You're supposed to do that previous session. It's too late. Next week you will submit your homework. Oh, just let me talk with other TAs to see that. What's their suggestion? Yeah. Uh, mm, I have put a PDF file and I sent an announcement last week to show that which parts you should submit for the part one. The most important part is the schematic, partial part of a schematic part. That's how the memory is interacted with the 8086 main, and uh, what is the multiplexing part of the A/D part uh, ports, and some control signals that you need to do that. That's it. And you should be careful to submit all of them by midnight on April 23rd, means that the night before our next session. Submitting Blackboard, I will make a submission folder for you. The part one of the homework, I mean, that we mentioned that you should submit on until the end of April 23rd about the schematic part. I will announce the submission that I have created the submission folder in email this week. There's no problem. I think no, we just like to motivate you to work on your projects until now. And I think all of you are working on your projects. Just be careful that it's 20% of your final project's grade, and you should be careful on this. Just try to work hard and submit it by the end of April 23rd. No, because you are working in group, then each group should submit just one folder. You don't need to submit that by two of you. I mean, both of you submit the project. Both, when I say both, it doesn't mean that both of you submit that in the Blackboard. One person from each group should submit the project, because the project is the same for two of you. There is no difference. And also be careful, because this project was just a homework during the last years, but because of this coronavirus problem, this became your final project. And I think you have had enough time to do your best on this project. Yes, you should combine your work, and both of you should be aware of all parts. Maybe your teammate is working separately and you are working separately. It doesn't mean that the parts that he's working, you shouldn't be aware of that. At least you should know what's the process of that, because in this project you're supposed to know be familiar with the architecture of 8086. Yes, that's great. One person should zip the file and all the project. You're welcome. Yes, I think I have told everything about the PCB layout.